Okay, my name's Julie Moore. I work for Stone Environmental and I designed this bioretention area, and I'm going to talk to you a little bit about how the water will actually move through our system. So we are capturing water from about 2/3 of an acre of impervious or hard surfaces, parking lots, sidewalks, and all of it used to flow right here to this catch basin, where it would drop down through the grate, enter a pipe, and head off along the side of your rec field, meaning it got no treatment. So any dirt, debris, things that fell off of the buses that washed into the grate would end up eventually in St. Albans Bay. So this system is designed, we've raised the top of this catch basin so no longer can the water get in here except during a really big rainfall event. Instead, the water is going to flow into the new bioretention area. It comes down this chute, and the first place it ends up is in what we call the sediment forebay or the stilling basin. And the idea of this area is the water will slow down. Any dirt or debris it's picked up will fall out, and then it will slowly filter through this stone berm. We want the stone to spread the water out so it doesn't come through in just one spot, but comes out all along the length. And the stone also helps pull out any material that may remain in the water. Once the water filters through this stone, it'll end up in what is actually the bioretention soil mix. On the far side of the stone berm, we have a mix that's approximately 1/3 topsoil, 2/3 sand. So it means it's really permeable. Water will soak right through it. We had done some soil testing here before we got started to figure out how much water the soil could actually take. The answer was not very much. So we put something called an underdrain in, which is a piece of pipe with holes in it. And so after the water makes its way through the sand, it will flow into this pipe with holes and actually end up back in the bottom of that catch basin. During a really big rainfall event, there are other ways for the water to get out. It will start to pool in here and then actually can leave leave the bioretention area through that large yellow dome grate. And during an extreme flood event, some might say a flood of biblical proportions, it would actually, the entire basin where we're standing right now could fill up and the water would leave the site again through that old catch basin grate. The idea, what we want here is the soil provides good treatment and it also slows the water down, because we're concerned about water pollution, but we're also concerned about how fast water leaves our developed landscape. And when it leaves fast, it tends to create erosion, and this system should address both of those concerns.